we go. Now I'm recording. So if there are no other questions, then let me just go where we left off, right? We were learning about the difference between inductive and deductive. I don't want to go through all these again. Oh yes, there we go. So this is what I had you do, right, to try to figure out if you could identify the ones that are inductive and deductive. And again, a good inductive argument means that if the premises are true, then the conclusion is very likely to be true as well. But the key word there is very likely. There's always a possibility, a logical possibility is left over that even though the premises are true, the conclusion could potentially be false. Okay? As opposed to deductive arguments in which the truth of the premises guarantees the truth of the conclusion. It would be logically impossible for the premises to be true and the conclusion false. So that's sort of your test, right? Can you imagine a scenario where the premises are true and the conclusion is false? If you can, then it's not a valid argument. And that's going to be the main test. When we do logic, that's what you're going to be looking for. You're going to be looking for the possibility in an argument that the premises might be true even though the conclusion isn't, right? If it's supposed to be a deductive argument and it fails to do that, if you can imagine a possibility where the premises are true and the conclusion is false, then it's not a valid argument, right? That means either it's an invalid deductive argument or it means it's just an inductive argument, right? Because all inductive arguments have that property. They're still good arguments though, so it's a little bit of a tricky thing sometimes to decide, and people do get confused about that sometimes, and maybe you haven't yet, but I'm just flagging that ahead of time. You might confuse an invalid deductive argument with a inductive argument, right? But that's a mistake. But hopefully just by doing these exercises, that sort of thing will get clear. Okay. So we did 1 through 3, 4. I'm guessing the dog knocked over the plant. He's done it a million times before, right? So if we were to put this in premise conclusion format, it would be something like, the dog has knocked over the plant a million times before, right? I'm saying dog instead of he, right? I'm saying knocked over the plant instead of it, right? If I were to put it into premise conclusion format, just to remind you, you weren't asked to do that, but I'm just reminding you, that's what you would do, right? The dog has knocked over the plant a million times before. The dog knocked over the plant. Yes, it's inductive, exactly, yeah. Yeah, it's based on previous experiences, right? So even if you try to provide a missing premise, you'd still have to think, well, could it be the case that they've done it before, but maybe didn't do it this time, right? It could have been something else. So yeah, that's an inductive argument. It's your best guess based on your observations in the past. But just because the dog has done it before doesn't necessarily mean they did. If it's based on personal experience, it's typically inductive. Yeah, a lot of cases it is. It depends on how you structure your argument, but in many cases that's what it is. It's sort of drawing from your past experience to try to explain the present or the future. Right? That's what a lot of science is gathering information from what we know about the past and trying to extrapolate. Right? That's why I say inductive arguments, even though there's always this logical possibility that the conclusion is false, even if the premises are true, they're more informative in a way, or they're more helpful and practical because they go beyond the information that you already have. In a deductive argument, all you're doing is, well, I've got this information. What do I know must be the case if that's true? You draw a conclusion, that's a deductive argument. But if you start with some sort of information, you say, well, based on that, what else could I guess is probably the case, right? Then you're going beyond the information that you're starting with, right? So it's actually adding more to your knowledge in a way. Whereas deductive arguments, you're just teasing out the knowledge that's already implicit. Okay, so yeah, so I don't want to generalize and say if it's based on personal experience, it's going to be inductive. But in many cases, depending on what your thinking is like, that is going to be the case, yes. Right? If you're using your personal experience as a guide for your behavior to try to decide what to do or to try to decide what you think is true, in most cases that's going to be an inductive argument because you might be wrong about the conclusion, right? If you're going beyond what's actually logically entailed by your personal experiences. Okay. Go. Yeah, good question. So, generally sure, but pay attention to what is actually being said and what the context is and what the person is talking about. Yeah, there's a bug flying around. I don't want a Pence moment here. I actually notice when bugs are flying around my head. Okay. It's going to rain all day tomorrow. The forecast said so. I believe I even used as an example earlier on. I said that's going to be an inductive argument as well, right? I mean, anything about what's going to happen in the future is likely to be an inductive sort of leap that you're making based on the past, right? Or based on some sort of authority, perhaps, like the weather forecast. Number 6, all cats are cute. Dorian is a cat, so Dorian is cute. Dorian is the name of my now very old cat. Doesn't look as on the surface cute anymore, but he's still cute, of course. Is that deductive or inductive? So ask yourself, if both of those premises are true, if they really are true, would the conclusion have to be true? Right, that's the thing, is you ask yourself, if they're both true, now that's an if, of course, right? So you might say that the premises themselves, yeah, exactly, so the premises themselves might be wrong, right? The premises themselves might be inductively based premises as well, right? If you were to have a sub-argument for all cats are cute, it would probably be an inductive argument. Right, but we're not evaluating the sub-arguments, we're evaluating the main argument here, which is all we have. All cats are cute, Dorian is a cat. If those premises were true, right, there could be an uncute cat somewhere, but we're asking, what about in a world where all cats are cute? Right, that's the question. That's how you figure out validity. You don't yet worry about whether the premises are really true, you just think to yourself, what if they were true? What if the world was such that all cats are cute? Dorian is a cat. In that world, wouldn't it have to be true that Dorian is cute because he's a cat and all cats are cute? Right? So that's what makes it deductive. So I think, Rachel, you're hitting on something, right? You're hitting on an exception to the rule for all cats are cute. It's just that we don't have to worry about that at this stage. Right? Later on, when you're done, once you figured out if it's a valid argument, in this case, if it's a valid argument, then you can ask, well, should I really accept all the premises, though? Right? Yes, exactly. Okay, glad that makes sense, right? Then you go back and you say, okay, well, it's a valid argument. The conclusion follows logically, right? All that means is if the premises were true, the conclusion would have to be true, naturally. Right? I hope you can see that. So you can say, okay, it's a valid argument. Okay, now let's see, are the premises really true? And then you might have some questions. Then you might say, well, premise 1 is not true. I've seen lots of cats that are not traditionally cute, right? There's a Facebook page, this cat is grumpy, right? All sorts of grumpy looking cats. You might come up with all sorts of counterexamples to that very categorical large statement about all cats. Yeah, and so that's a totally reasonable issue to bring up with the argument. But it won't affect whether or not the overall argument is inductive or deductive, because for that, all you have to worry about is the hypothetical situation, right? If all cats were cute, and if it's true that Dorian is a cat, would it logically follow that Dorian would have to be cute? Yes. Yeah. Okay. I bet Pierre is rude. After all, he's French, and most French people I've met are rude. So again, do the same sort of test, right? Let's suppose that Pierre really is French, and let's suppose that this person really only has met, or not only, it says most, let's suppose that most of the people that they met, French people that they met, were rude. Could it still be logically possible that Pierre is one of the French people that is not rude? Right? Because again, the question is, if the premises are true, could it logically, conceivably be the case that the conclusion is false? Right? Yeah, and I forget how I phrased the question, so I can't remember if yes is correct or not. It's logically possible, I think, is what you're saying yes to, right? It may be true that Pierre is rude, and you've just mostly met rude French people, and yet it could be true that Pierre turns out to be a non-rude French person. Right? That's the idea here. And of course, there's all sorts of other problems there. Then, yes, it's inductive. Yes, it's inductive because it's possible for the premises to be true and the conclusion false. Right? With the Dorian example, that's not possible. This is not. It doesn't make any sense to say that all cute cats are cute and Dorian is a cat, but Dorian is not cute. Wait, we just said all cats are cute and Dorian is a cat, so he must be cute, right? That's a logical contradiction. But in 7, it's not. It's a good guess if it really is, right? So if it's really true that this person has met, let's say they've met hundreds of thousands of French people, and most of them are consistently rude. If that were even the case, which of course is an absurd thing, but suppose that was the case. Suppose they've met tons of French people, and almost all of them were rude. Well, so then it's a good guess that Pierre is rude. It's a pretty good guess. It's a strong argument if we grant the truth of the premises. But for all that, even if we grant the truth of the premises in 7, the conclusion might still be false. Pierre might be one of those non-rude people that person has met before. Yeah? Okay. So that's what makes it a strong inductive argument, right? But it is not a deductive argument. This one's a bit weird. Sometimes I like to throw weird examples in there just to make you think. What do you think? Is that inductive or deductive? Yeah, it's probably deductive, right? I mean, given what we mean by 10 and 8, this is what you'd call in philosophy an analytic truth, right? Of course, yeah, that 10 automatically means more than 8. So if anyone has 10 fingers, they must have more than 8 fingers, right? That's just what the words mean. So yes, that would be a deductive argument as well, because if the premise is true, if Lisa has 10 fingers, then the conclusion must be true. She's got more than 8 fingers, because 10 is more than 8. Right? You might want to put in the missing premise, right? 10 is more than 8. Then you can really see that it's deductive. Lisa has 10 fingers. 10 fingers is more than 8 fingers. Therefore, Lisa has more than 8 fingers. Yeah. Okay, any questions? That's just the general sort of idea about the difference between inductive and deductive. And we're going to come back to inductive reasoning later. Now we're going to focus on deductive arguments. And since deductive arguments are all about the overall structure of the argument, that's what allows us to do logic. That's what allows us to take the individual sentences out and replace them with variables instead. Because look at number 6. All cats are cute. Dorian is a cat, so Dorian is cute. You could substitute anything for cat, cute, and Dorian. Right? You could substitute anything in there, and it's still going to be true, or it's still going to be valid, right? So look at 6. All elephants are gray, right? Simba is an elephant, so Simba is gray, right? It's valid. Again, you might question the premises, but that's valid. Anything you plug into that format is automatically going to be valid, right? So you can already see you could potentially just take out all the words and just say all A's are B's, right? This is an A, therefore this is a B. That sort of thing. You can look at just the structure of the argument and see that it is valid. Okay. maybe that doesn't make sense to you yet. Before we get to that, let's before we actually move right into logic itself, I should explain these concepts a little bit. Now, validity I've been talking a lot about, and soundness I have told you about it before, I think, but it wasn't official yet. So now let's make it official. I've told you before, right? When it comes to any argument, whether it's inductive or deductive, you've got two main jobs to do in terms of evaluating the argument. You have to make sure that the conclusion actually follows from the premises, either inductively, right? So that if the premises are true, the conclusion is probably true, right? You want the argument to be strong. Or they need to support the conclusion deductively. So you want the argument to be valid. So that has to do with the support that the premises give to the conclusion. And that's just a matter of the argument structure, right? That's a matter of how the argument is arranged. And then there's the problem of, well, are the premises actually true? Right? So two different components there. And we bumped into that just a moment ago, right? Yes, the argument was deductively valid, but of course one of the premises may have been false, right? The all cats are cute. So we can see that there's two components. You were able to see that that argument is valid because if the premises were true, the conclusion would have to follow logically. We get a check mark for validity there, but the premises aren't all true, right? One of the premises is false. So the argument as a whole fails. It's not what we call sound, right? So sound refers to deductive arguments. Sound refers to deductive arguments that are valid and have true premises, right? So you need to check for validity and truth, right? Validity and truth. Validity means, do the premises actually support the conclusion? Truth means, are the premises that we're using actually true? Okay, so those two components, you need both of those. Okay, so just reminding you what a good deductive argument looks like. And instead of saying good from now on when we talk about deductive arguments, we'll talk about valid arguments. Right? So in a valid argument, if the premises are true, then the conclusion must be true. But you don't want an argument to just be valid, right? It's very easy to come up with valid arguments with bad conclusions because the premises are wrong, right? So you need to have both validity and truth. And when you have both, the argument is sound. And a sound argument is the best, right? Sound argument is where it's at because that means you can trust that the conclusion is true. Right? So long as you were correct in identifying the premises as true, right? There's always the possibility that you made a mistake. But in terms of evaluating the arguments, those are the steps, right? Do you think the premises are actually true? And do the premises support the conclusion? Right? So once you have validity and true premises, the argument is sound, right? And notice all the premises must be true, right? You can't have a mix. For an argument to be sound, each of the premises listed must be true, and they must support the conclusion in a deductive way, meaning if all the premises are true, the conclusion must logically be true. Basically that, right? So by definition, the conclusion of a sound argument has to be true. Right? Because when you call an argument sound, you're saying both the premises are true, and you're saying if the premises are true, the conclusion must be true. So if you say both of those, that means you're saying the conclusion is true. Right? So to identify an argument as sound means that you're agreeing with its conclusion. If you go through and evaluate an argument and you realize that it's sound, right, you agree with the premises, and you can see that they deductively entail the conclusion. Right? That means they support the conclusion in this deductive way. If you see both of those, but you don't agree with the conclusion, there's something wrong going on there. Right? It may be one of those things that we talked about in the beginning of the semester, where people are not willing to revise their belief systems. Right? So that conclusion that you see is part of a sound argument, maybe it goes directly against something else that you think is true. So then you've got some internal inconsistencies going on, because you see that the premises are true and you see that they entail the conclusion, but you don't want the conclusion. Now, maybe you don't recognize yourself in this. Maybe that hasn't happened. But that's definitely something that's possible. And I'm just reminding you, well, then you've got some work to do, right? You either got to go back and show that maybe one of the premises is actually not true or acceptable to you, or maybe there is a problem with the logic of the argument. All right. Just something to watch out for. Right? Be willing to revise your beliefs if it makes more sense overall, right? If you can overall walk around with less internal inconsistencies, that's going to be better. So if any of the premises of a deductive argument is false, the argument is not sound. And all that means is you cannot accept that argument, right? Once you've said an argument is unsound, you haven't really learned a whole lot about whether or not the conclusion is true or false. All you know is that argument don't work. Right? So I want to make that clear. This has come up before. Right, so there I'm just saying, it's got to be valid as well, right? So again, just reiterating, an argument must be valid and have true premises. And so the last part there, this is all what I was just saying is, can you read that? I don't know why it's kind of weird like that. That little bar underneath is not disappearing. Let me see really quick. Oops. There we go. That's a little better. All right. So just a reminder, right? So if you're evaluating someone's argument and you identify a problem, all you've done is identified a problem with that particular argument. You haven't really shown that the conclusion is false or anything like that. Right? It's a mistake that people sometimes make. Is that if you can show that someone's argument is wrong, that it means that their position is wrong. That's not necessarily the case, okay? So just be careful about that, right? So you have to look at all the arguments, pro and con. You can't just look at one and decide, well, that one doesn't work, so their conclusion must be false. That's not the case. It just means that that argument on its own fails to prove that the conclusion is true or probably true if it's an inductive argument. That argument failed. That doesn't mean that there's no other argument for it. Right? I gave the example of if I'm a wizard, I'm wearing a shirt. I am a wizard, therefore I'm wearing a shirt. Right? It's a valid argument, but it's not sound because I'm not a wizard. Right? One of the premises is false. So you could say, well, that's a bad argument you got there, right? That's a bad argument for the claim that I'm wearing a shirt. Yes, that's a bad argument, but I am wearing a shirt. Right? That's the point here. Yeah, so you could have a bad argument for a true conclusion. So you have to be careful. That's all I'm saying here. Right? It's called the fallacy. To point out the fallacy in someone's argument, and then say that therefore the conclusion is false. That's a mistake. Okay. Do you have questions about that? Is that confusing to anyone? Okay, so just to give you a visual here. Right, there are different ways that an argument can be unsound. There's only one way for it to be sound. Right? That's if it's valid and has true premises. So the first one is valid. Right? If I'm a wizard, then I can do magic. I am a wizard. I can do magic. Right? It's valid because if the premises were true, the conclusion would be true. Right? So it's valid. Okay, great. I've got that going for me. I'm valid, right? Says the argument. But then we evaluate for truth. Are the premises in fact true? The first premise looks like it's true. I think that's sort of a definitional truth, right? If you're a wizard, you can do magic. That's what makes you a wizard. You know, I am a wizard. That premise, unfortunately, is false. So the whole argument is unsound. Right? That just means I did not provide a good argument for the idea that I can do magic. It doesn't mean that the conclusion is automatically false, right? You might have to think about some other things to get to that conclusion. Right? But all you can say is, well, it's got a false premise, so that's not a good argument. So you can dismiss it, right? Try a different argument. So what about the one that's the brown one, top right? It has true premises, right? If I'm hungry, then I'll have a snack. I'm just assuming, for the sake of argument here, that this could easily be a true an argument with true premises, right? If I'm hungry, I'll have a snack. I'm not hungry, therefore I will not have a snack. Okay, those premises might be true, but even if the premises were true, the conclusion doesn't necessarily follow, right? Do people only eat snacks when they're hungry? No, people eat snacks for fun, right? Go to a movie theater, you don't have to be hungry to order some popcorn, or you're hanging out at night and you just get hankering for potato chips. It doesn't have to be hunger, it could just be for the fun of eating, right? So even if the premises were true, the conclusion does not logically follow in this case. So that's also unsound. So even if the premises were true, and let's just suppose they are for this argument, that's great, right? The argument says, I've got that going for me, I've got true premises, but is it valid? No. The conclusion does not follow logically from the premises. Those premises could be true, even though I'm sitting here having a snack, right? It's totally consistent. Whereas for the first one, that it would be inconsistent to say, I'm a wizard, or if I'm a wizard, I can do magic. I am a wizard, but I can't do magic. That wouldn't make any sense. You'd be contradicting yourself. But in this one, you wouldn't be contradicting yourself, right? It could be true that whenever you're hungry, you have a snack, and it could be true that you're not hungry right now, but you're still having a snack. Okay? And then, of course, you can fail in both ways. You can go wrong on both accounts, on validity and truth. Right? If I'm a wizard, then I can do magic. I can do magic, therefore I'm a wizard. Maybe this one's not clear to you right away that it's not valid, but it's not valid. It does not follow. Here's one nice counterexample. What if I am instead a witch, right? It's a good time to talk about witches and stuff, right? Halloween. In the philosophy class, we always end up doing philosophy of mind during Halloween, when we talk a lot about things like ghosts and zombies because they're philosophically applicable. So, yeah, that class is a lot. I mean, this class is fun too, but this is a lot more hard work for me as well. The philosophy class is a lot of fun if you're into that sort of thing. Okay, so anyway, the third one there, the one in green, is unsound because it's both not valid and it's got a false premise. I can't do magic, I'm sorry to say, right? I can barely do, magic with coins for my kids or something like that. I'm not very good at that even, so I can certainly not do real magic. So it's a bad argument, right? So it fails. So those first three arguments each fail because something has gone wrong. Either the premises are not true, or one of the premises isn't true, or it's invalid, or both. What you want an argument to be is to be valid and have true premises, right? So the final one is valid and has true premises. If I'm a wizard, I can do magic. Yeah, that's true. It follows from the definition of being a wizard. Wizards are beings who can do magic. I can't do magic. It's true. I can't do that kind of wizard magic. So it follows that I'm not a wizard, right? If I were a wizard, we've already established, then I would be able to do magic, right? So it's one of those cases where, ignore what we're talking about for a second and just look at the structure of the argument. And it says, if A, then B, not B, so not A. Right? Because if A were true, then B must be true. We've established that, right? So if we're doing that sort of test, imagine the world was like this, where all wizards can do magic, but I can't do magic. What would logically follow? I'm not one of those wizards, right? Because we've imagined this scenario where all wizards can do magic, and I can't do magic. So I'm out of that club. I'm not a wizard. It follows logically from the premises, and the premises are actually true. Right, so here I've provided you with a deductive argument for the claim that I am not a wizard, right? I've proven it to you, hopefully, if you agree that the premises are true. Okay? You might have reservations about that, right? But that's always going to be up to you as an individual. Not to say that you are the one who determines what's actually true. I'm not saying that. I'm not being subjectivist about this or relativistic at all. I'm just saying ultimately it's going to be in your hands, on your shoulders, right? You are the one that has this sort of what I call epistemic responsibility. You're the one evaluating the arguments. So you have to decide on your best abilities whether or not you think a premise is likely to be true or false. Right? Here, I thought this was a pretty straightforward argument where I don't think anybody's going to have a problem with those premises. Right? So I thought that was a good example. So just to show you, right, what you need for an argument to be sound, and soundness is what we're looking for. Even though we're going to focus a lot on the validity part of it, we're going to focus a lot on the part that's about whether or not the inference that we've made is valid. We're focusing a lot on that, but there's always going to be those two different aspects to evaluating an argument. Right? So if we're looking at an inductive argument, we would talk about strength plus true premises, right? Equaling what we call a cogent argument. Right? So the vocabulary is slightly different, but we're talking about the same kind of thing. We're talking about whether or not the premises are true, and then we're talking about whether or not those premises provide support for the conclusion. In a deductive argument, that support is one of that we call valid when it's correct. In an inductive argument, when the support is right, we call it strong. Okay, questions? Making sense, I hope. That was just a quick overview so you could kind of see the different ways in which an argument could be sound and unsound. But now let's look at some examples of just validity and invalidity, right? So look at this example. All dogs are mammals. All cats are mammals. All dogs are cats? Does that follow? Can everyone see that that's wrong? I assume everyone's typing that that's invalid, right? Exactly, yeah, you can see that, right? And hopefully you can see that it's not just because we're talking about dogs and cats and mammals. Whatever you substitute for those terms, this argument will never be valid. You might accidentally end up with a true conclusion following this format, but you wouldn't be able to know that the conclusion is true based on the argument, because this argument format never works. It's never a valid argument. So whenever you go, all P are Q, all R are Q, therefore all P are R, right? It'll never work, right? Or just use the letters in there, right? So we don't have to be talking about dogs or mammals. We could be talking about anything, right? So if you said all ducks are mountains, all coconuts are mountains, therefore all ducks are mountains, right? It doesn't work. It doesn't matter what you put in there, right? So this is what allows us to move into the realm of pure logic. We can leave the sentences behind. We don't have to even know what we're talking about in order to judge whether or not the argument is valid. Okay? If God exists, then there are objective moral truths. God doesn't exist. Therefore, there are no objective moral truths. It's an invalid argument. Notice that we don't have to, like I said, you don't at this point have to worry about whether the premises are true, right? That's kind of the cool thing about learning how to evaluate an argument. You don't have to be so caught up on the premises, right? You might be a theist, someone who believes in God, and right away you think, well, premise number 2 isn't true. Right? I know that God exists. That's not true. Right? You lousy atheist or something like that. And that would be totally fine, but you could still evaluate for validity. Right? The argument might still turn out to be valid. In this case, it does not. As you will learn, you might not think this right away, but this argument format is not valid, and you'll see why. Right? This follows the same format as the if I'm hungry, then I will eat. I'm not hungry, so therefore I will not eat. And it follows the same format. It's an invalid format. You cannot trust an argument like that. So it may be true that there are no objective moral truths. Right? Premise 1 might be true. Premise 2 might be true. But the argument as a whole fails because it's not valid. Right? The conclusion could be false, even if the premises are true. Right? It's logically possible for both of the premises to be true, and yet for there to be objective moral truths for some other reason. Right? It might have nothing to do with God. Right? So that's the point here. You simply think, okay, let me imagine that the world is such that the premises are true. Let me imagine such a world. In that world, would it be possible for the conclusion to be false or for its opposite to be true? In this case, the answer is yes, yes. It could be true that God's existence would mean that there's objective moral truths. It could be true that God doesn't exist. It could still be true that there are objective moral truths that have nothing to do with God, right? So now this is just a specific example, so don't get too caught up on that, right? What's important is that every argument with this format is going to end up being invalid, because that argument format just does not work. It's not trustworthy. You could have true premises and end up with a false conclusion. In a deductive argument, that will never work. In a valid deductive argument, that'll never happen. Right? In a valid deductive argument, you'll never end up with a false conclusion if you start out with true premises. Okay? That's going to be the main objective in doing logic, right? And if we're thinking of logic as a game, that's the objective, is try to figure out, is it logically possible to have true premises and a false conclusion? If there's any way that that's possible, logically speaking, without contradiction, then it's an invalid argument. So to show you that this doesn't work, we can change the subject, and you can more easily see that it doesn't work. If I am a dog, then I'm a mammal. It's true, right? Dogs are mammals. So if I were a dog, I would be a mammal. Yeah, it's true. Well, I'm not a dog, am I? No, that's right. I'm not. Does that mean that I'm not a mammal? I'm waiting because I see people typing, so. No, it doesn't. It doesn't follow, right? Yeah. And that's not because we're talking about dogs and mammals. It's because the structure of the argument. Now, I'm using this example because you can easily see that both of the premises are true and yet the conclusion is false. The words if and then are very important. Yeah. Because they're establishing a relationship between two different things, right? Notice that premise number 1 doesn't say that I'm a dog, and it doesn't say that I'm a mammal. It just says that if I were a dog, I would be a mammal. Which is true. And premise 2 is true. And yet, it is not true that I am not a mammal, right? Because I am a mammal. So I'm giving you this example because you don't have to follow the logic of it. Just simply look at it as a list of statements and realize the first 2 statements are true, the third one is false. That means that the conclusion does not follow logically from the premises. And it would only follow logically from the premises if the format was right. But the format is wrong, and the format is wrong in this one as well. Anything that goes, if A, then B, not A, therefore not B, in this deductive kind of way, it's not going to work. It's going to be invalid. Okay. Well, there's another one that's not valid. Right? And I'm using a lot of the if. You don't have to have deductive arguments with the if-thens in there, right? I also did it in using categorical language, all, some, or none, and we'll get back to categorical logic later. And there's all sorts of different ways to do it, but if-then does end up being very important in logic and in propositional logic. If we have moral responsibility, then we must have free will. We have free will, therefore we have moral responsibility. That does not work either. It's invalid. Now, for a lot of these argument formats, you'll begin to recognize them, and I'm going to name them for you so you can simply recognize them. And then later on, you'll actually be able to do the work to show, to prove that they're invalid. Right now, I'm just telling you, right? You'll be able to see for yourself that no argument in this format is valid. It never works. It's always an invalid argument where you cannot trust that the conclusion is true based on the argument itself. And maybe you've got some other argument, but this will not work because it follows a wrong format. Right, so here, again, this might not be entirely clear, right? I give you a philosophical example because this gives you a taste for how easy it is to be misled when people are when people are discussing something a little bit more abstract or esoteric, but this could be politics for all you know, right? Where terminology is thrown around, and people might present this type of argument and it might scan kind of nicely, right? It kind of seems to work. If we have moral responsibility, then we must have free will. We do have free will, so we must have moral responsibility. It kind of sounds right and tempting, right? And this is mostly because you're not fully grasping maybe the content of it. But then when you see a more down home example, a more everyday example, it becomes a little bit more clear. So if I did this instead, you could see right away, of course this format does not work. Right? Again, this is the same format as this one, where here maybe you're not entirely sure about it, but once you look here, then you realize that the format does not work. If I'm a millionaire, then I must have money. That's true. Right? If I'm a millionaire, then I must have money. Yeah. I have money. Yeah, I have a little bit. Teaching doesn't pay that much, but I'm not complaining. Right? There's some. Does it mean then that I'm a millionaire? No, of course not. I don't even need you to type no. You know that, right? And you can see that it simply does not follow from the premises. Even if both of the premises were true, and they are, the conclusion does not follow. How do we know that? Well, I am not a millionaire, right? So it's easier to see here because once again, I've given you a list of statements that independently you already know premise 1 and premise 2 are true and the conclusion is false. But what that means is that this argument format is unreliable because sometimes even when you plug in true premises, you end up with a false conclusion. Now, sometimes you might get lucky. We've looked at that before. You can have an invalid argument that happens to have a true conclusion. Okay, you get lucky sometimes, but that's getting lucky. We don't want an argument format to be unreliable in that way, right? We want the argument form to be valid, and valid means that as long as you're putting true premises in, you will always get a true conclusion out. Right? This format, if A then B, B therefore A, is not consistent. You could plug in things for A and B and end up with true premises and a false conclusion. That's what happened right here. And that means that argument format is generally unreliable. You can't rely on an argument format that goes if A then B, B therefore A. Because in many cases, even if the premises that you've created around that in that format are true, you might end up with a false conclusion. And the whole point is to only use argument formats or argument forms that are reliable, such that if I plug in true premises, I will always get a true conclusion out. You can think of it as like you can think of argument formats as boxes, little machines. Some of them work really well, some of them are defective. The ones that work well, as long as you put true premises in, you will always get a true conclusion spitting out. Always. The ones that are defective, sometimes they'll spit out a true when you put true premises in, but sometimes they'll spit out a false. Those ones are defective. We just can't do anything with those boxes, right? So those boxes, anything that follows that, you got to just push to the side. It's not reliable. We want our argument formats to be reliable such that if the premises are true, the conclusion is true every single time. It's not even logically possible to have the premises be true and the conclusion false. Okay? So the two of the ones that I just looked at are so common that they have names, and people make these mistakes all the time. That's why they have these names. Denying the antecedent, affirming the consequent. Right? Anything in this format, if A then B, not A, therefore not B, anything in that format is not going to be a valid argument. Right? So the example that I keep using, just to remind you, if I'm hungry, then I will have a snack. I'm not hungry, so I will not have a snack. Not correct, right? That's invalid because the conclusion could be false, even if the premises are true. And so anything that follows that this format, if A then B, not A, therefore not B, anything that follows that format is going to be invalid, and any argument that has that is not a good argument. Okay. It's called denying the antecedent because when you have an if A then B statement, the first part is called the antecedent, the A, and the B is called the consequent. Okay, so what you're doing in the second premise there is you're denying the truth of the antecedent. The antecedent, again, is in the conditional statement, the if-then statement. If A, the antecedent, then B, the consequent. The second premise says not A, right? Not the antecedent. It's denying the antecedent. And then in the conclusion, it denies the consequent. But we're naming this format based on what it does in the premises, right? Premise number 2 denies the truth of the antecedent. It says that A is false. And then it concludes that B, therefore, is false as well, which is an improper move. It's not logical to say that. It's, yeah. Yeah, already looked at that. And then the other one we looked at was affirming the consequent. Where again, you can see the language that I'm using, right? In an if-then statement, the first part, the part right after if, is called the antecedent, and the part right after then is called the consequent, right? If A, then B. So B is the consequent. So what is premise number 2 doing? It's affirming the consequent. So these are two common invalid argument forms. So anytime you see something in this format, you know that it's not deductively valid. Okay. Now, that said, inductively, you might use this kind of reasoning sometimes. Okay. So, for example, look at affirming the consequent. If A, then B, B, therefore A. Inductively, that might work sometimes, right? You might notice that whenever A happens, B happens, and B hardly ever happens for any other reason. Then if B happens, then you could say, well, there's a high likelihood that A is the reason for it, right? So we do that kind of stuff in science, but then it's going to be inductive, okay? If it's just presented in this format, it's pretty obviously meant to be a deductive argument, then it's just going to be a mistake. At the very least, you'll be able to say, well, it's not deductively valid, so I cannot accept this as a deductive argument. Again, just wanting to flag certain complications before they arise. Sometimes maybe I'm creating the problem by bringing it up. Maybe you were never going to think about it. But I wanted to bring that up in case you were ever thinking about that. If you see something that kind of looks like affirming the consequent, but it makes sense, well, it's probably not a deductive argument. It's an inductive argument, okay? But here, focusing just on anything with this format, you'll be able to say that is deductively invalid. If the gnome is drunk, then she's grumpy. Guess what? She is grumpy, so she must be drunk. Maybe this one's not as easily detectable as the other ones, but it's the same sort of thing. Granted the truth of the premises, right, it affirms the consequent, right? Yes, exactly. And that's wrong, right? So if the gnome is drunk, I keep doing these spoonerisms where I juxtapose the letters around. I said if the drome is nunk. If the gnome is drunk, maybe I'm drunk. If the gnome is drunk, then she's grumpy. She's grumpy, so you must be drunk. Well, no, right? It may be true that whenever the gnome gets drunk, she gets grumpy, but she could get grumpy for another reason, right? So simply because she's grumpy does not automatically mean that she must be drunk. She could be drunk for another reason. If A is B, then C. Yeah, you should rather say if A then B. Right? You don't have to put the is in there. The A, Anna, can stand for the gnome is drunk, right? So A will stand for a whole statement, right? The variables that we're going to use, the A's and B's or the P's and Q's, they stand for whole statements. Not all logic is like that, Anna. So some logic is more like what you're taught, how you're breaking it down. Some logic does it in that way. But in propositional logic, we get this luxury of just summarizing an entire sentence with an A or a B or an X or a Y or whatever you want to use. So this would be something like if A, then B, B, therefore A. Yeah, just to keep it simple. Well, I do that too. It's okay. If-then statements, instead of calling them if-then statements all the time, I'm going to call them conditionals, okay? Hopefully you can remember that terminology. So it's just a piece of vocabulary, okay? Just try to get it in your head. A conditional, right? A condition, right? There's a condition for something. If this happens, then this happens, right? It's a conditional. There's a condition for something. So think of it in that way. Right, so if-then statements are called conditionals, and sometimes I get ahead of myself, right? So I already explained this. There's two parts to a conditional: the antecedent and the consequent. Right. So if every conditional statement has this general format: if P, then Q, and P is going to be a whole state, true or false statement. Yeah, yeah, exactly. Sometimes it gets taught in such a way that you're just supposed to remember those words, affirming the consequence, that you're supposed to just put it to it and remember. But if you realize that it actually says what the argument is doing, then it really helps to understand the vocabulary, because you might kind of forget what they're called, but you can just look at that second premise and ask yourself, what is that second premise doing? Right? So then if you know if it's affirming the first part or affirming the second part, right, or denying the first part or denying the second part, yeah, that will help. Yeah. Yeah, so just remember that, right? So P stands for any true or false sentence. Q stands for any true or false sentence. It could have said if A then B. It could have said, that part just does not matter. We can use anything to symbolize a statement. So that I'm using a P or a Q is not important. You could use any letter that you want. Okay, theoretically you could use symbols and emojis, right? All you need is just one symbol to symbolize a true or false statement. Yeah. So then the first part is going to be called an antecedent, right? The first true or false statement in an if-then statement, and then the second true or false statement in an if-then statement. And notice that, right? An if-then statement is what you call a complex or composite or molecular statement, because if P then Q type statements, they have multiple statements within them, right? There's two separate statements nestled within one big statement, right? P is a sentence on its own. Q is a sentence on its own. And then the conditional puts both of them together into one big statement. Yeah? That's going to become important later on. So if getting back to actual language, to actual English language rather than P's and Q's, right? So this would be an example of a conditional statement, right? If it's raining, then I will bring an umbrella. So if I were to ask you, say in a quiz, I might ask you, here's this conditional statement. If it's raining, then I will bring an umbrella. Which one is the consequence? Then I would want you to know the consequent is I will bring an umbrella. The consequent is not then I will bring an umbrella or anything like that, right? It's simply the statement I will bring an umbrella. And if I were to say, how will you deny the antecedent? You would say something like, it's not raining. Yeah? Or deny the consequence. I will not bring an umbrella. So that's just breaking down some of the vocabulary so we can more easily talk about these statements. Okay, so we looked at two invalid argument forms, and we called those out because they're very simple and they exist all over the place. So it's good to just be able to recognize them. So this is sort of a heuristic device, right? You just get those invalid argument forms in your head and learn to recognize them. Learn to recognize it's always a mistake to affirm the consequent or deny the antecedent in the second premise. Right? Those argument formats are always invalid. And you can also easily learn to recognize four easy valid argument forms. Beyond these ones, you're not going to be learning a whole lot of names of forms because there are literally an infinite amount of argument forms. Okay, it's a bit like math in that way. You could have all sorts of arguments, and they can get very complicated. And we don't have names for all of them. Rather, we have a technique for figuring out whether or not they're valid. We have a method, or I like to say, we have a game we can play to figure out if any given argument is valid or invalid. But you don't necessarily have to do that for these easy ones, even though we will for practice. But these easy ones are easy to just recognize, okay? So you simply learn to see, if you see an argument with this format, you know at least the form is correct, right? The validity part of the equation is there. You then simply have to figure out, are the premises actually true? So this argument format, unlike the other two, is always valid. If A, then B, A, therefore B. That's always going to be true. That's always going to be valid. Might as well use my own mistake to point that out. People sometimes get confused with the terminology. Valid refers to the whole argument, right? Is the argument valid? That means, does the conclusion follow logically from the premises? Truth is with respect to individual statements, premises, conclusion, perhaps parts of statements, right, like an antecedent and a consequent. That's what truth is about. Validity applies to the whole argument, right? So this argument is valid, and that means that anything you want to put into the A and B, any sentence you come up with, you can stick it in there and it's going to be a valid argument. Not necessarily sound, because, A might be a false premise that you're coming up with. But the argument will still be valid, because if the premises were true, the conclusion would have to be true. Right? You can't have the premises be true and the conclusion false. That would be a contradiction. I hope you can see that. Imagine it for a second. Imagine that the world were such that if A is true, then B is true, everywhere, all the time. Whenever there's an A, there's a B. And now we've noticed that, there's an A here. And then you say, but there's no B. Well, you would have contradicted your premises. According to your premises, there's a B whenever there's an A, and there is an A, so there would be a B. Right? So that's what it is for an argument to be valid, is imagine that the conclusion is false. Would that contradict your premises? Yeah, that would. So it must be true then to be consistent. Right? If we're assuming that, for the sake of argument, the world is such that the premises are true, in such a world, this conclusion would have to be true, no matter what the A's and the B's stand for. And that's called the modus ponens. It's a Latin phrase. The Romans sort of took over some of Greek philosophy, and of course everything became Latinized in Europe. So the logicians and stuff who worked on logic, that they inherited from Aristotle, the Greek philosopher who first formalized logic. We'll study his logic later on. We're going to do categorical logic, and that goes right back to ancient Greece, right back to one of the great philosophers of all time, the forefather of science, and the person who invented formal logic. Right. Okay, I got off on a. Oh, because I'm explaining where modus ponens came from. Yes, those medieval logicians who were working with the Roman language, right? So they gave these Latinized names to a lot of the logic terminology. So here's the classic example of a modus ponens. If Socrates is human, then he's mortal. Fallacy probably comes from Latin. If not Latin, then Greek, most likely. I can't think of top of my head what the etymology of fallacy is. I think. What could it be? Yeah, I'm not sure. Yeah, yeah, it's interesting. A lot of our more technical words come from either Greek or Roman, don't they? Then. So there's the classic example. Hopefully you see that it's valid, right? If those premises are true, then the conclusion must be true. Yeah. Okay, so that's modus ponens. Okay. So see if you can get that word. I don't know what mnemonic device you can use to get that word, that the terminology for it in your head. Modus ponens. You could also think of it in this way. You could use the terminology that we used for those invalid arguments forms, right? You could call this affirming the antecedent, right? Because again, you're looking at the conditional statement, the if-then statement. The first part of it says A, but then in the second premise, you're affirming that. You're saying, yes, A is actually true. Because notice, premise number one is not committed to the truth of A or B. This is something to recognize about conditionals. And in any if-then statement, when it says if A then B, notice that statement says nothing about whether A is true or B is true, or A is false or B is false. It's not saying anything about that. All it's saying that is if A is true, then B has to be true. So then when in the second premise we say, hey, guess what? A is actually true. Now we're committed to our conclusion. Right? If we're committed to the idea that if A is true, then B is true, and we're committing ourselves to A being true, then we've already committed ourselves to B being true, right? On pain of logical consistency. Right? Okay. So I hope you're starting to see what's key in deductive arguments. It's about being logically consistent. Yeah. You can't have a conclusion being false and the premises being true in a valid argument. It just is not going to happen. It's not logically possible. Okay. And here's another valid argument form. Confusing, right? Because, yeah, now we're denying something, right? But we're not denying the antecedents, like in the invalid argument form. We're denying the consequent, and that's perfectly reasonable. Right? If you say that if A is true, then B is true, but B isn't true, then you know that A can't be true. Right? Because we'd already said in premise number one, if A is true, then B is true. So if B isn't true, then we know A can't be true, right? I hope you can see that, just without even using everyday English. Hopefully you're starting to sort of see the format and how the format is what's key here, and that it doesn't even matter what sentences or statements you plug into A or B. This is never going to work. Or sorry, this is always going to be valid. The other ones are never going to work, right? If A, then B, not A. Yeah. Now, when I took logic for the first time, I was stuck on this one for a while. For some reason, I kept thinking that it's not right. that you could somehow, sometimes have A, but I was just wrong. Okay. If you think about this hard enough, you'll figure it out. Right? Again, you're doing this sort of hypothetical exercise, right? You're asking yourself, what if it really were true that all A's, whenever there's an A, there's a B, or if A is true, then B is true. Let's commit ourselves to that, is what I was saying. Let's commit ourselves to the idea that whenever there's an A, there's a B. Well, there's no B. Well, then there cannot be an A. Right? If there were an A, there would be a B. That's what premise number 1 said. Premise 2 says there's no B. Took you 2 years to think Socrates was mortal. Okay. Well, do you thought he was immortal before? Therefore, yeah, and therefore is a conclusion indicator, right? So yeah, it means we're coming up with, it's like the two premises are leading up to the conclusion. They support it. We say, therefore, this must be the case. Oh, I see, the argument format. Yeah. Couldn't figure out the Socrates is mortal thing. Yeah. Okay, so that's a modus tollens. So here's an example, right? So again, trying to figure out validity. Your question is, if I imagine all the premises to be true, could the conclusion possibly be false, right? So let's suppose it's true that the lights are all off in someone's house. Suppose all the lights are off. And then let's suppose that it's true. If someone was home, they would be on. Right? That's a big if, maybe, or maybe that statement might have not been true, but we're imagining a case where if somebody's at that home, the lights would be on, but the lights are all off. What does that mean? What does that logically entail? Nobody's home. This follows that modus tollens format. If A, then B, not B, therefore not A. So yeah, you might just have to spend a little bit of time looking at these formats and puzzling over them. But at the end of the day, they're not that complicated, and you could kind of hopefully see, if you use some everyday examples, why that's the case. Right? And why, if you're committing yourself to the premises, then you cannot avoid that conclusion. That conclusion must be true if you assume that it's really true that whenever A is true, then B is true, but in this case B isn't true. Then that would mean in this case A is not true. Okay. That's modus tollens. A hypothetical syllogism, it's another one that you should just be able to recognize. And this one's pretty intuitive for most people, I think. Right? If A, then B. If B, then C. What can you conclude then? Well, you conclude that if A, then C. Right, here's a good example of, this shows a lot better this idea that the conclusion doesn't really say anything extra beyond what the premises already say. Right? That's the feature of valid deductive arguments, is that the conclusion is not really going out on a limb at all. It is simply saying something that's logically entailed by the premises. And of course that's true. If every A leads to a B and every B leads to a C, then of course every A leads to a C. It just logically follows, right? Hopefully that's clear. That one's probably clearer than most of the other ones. Silly example. No one would actually really argue this, right? Sometimes these argument examples that we use, myself included, but this is a widespread practice. A lot of times the toy examples are not something anyone would actually argue about, but the point is to show the logical structure, right? That's the point of it. And this has the logical structure of a hypothetical syllogism like that, right? When it rains, water falls out of the sky. When water falls out of the sky, everything gets wet. If both of those things are true, then it would follow logically, when it rains, everything gets wet. Okay. Silly example, but hopefully you can see that the conclusion logically follows from those premises. So that's a hypothetical syllogism. Finally, right? So again, to review what we're doing here, there are some basic argument formats that you can put an argument into that you can learn to recognize very easily. And you looked at two that were always invalid. So anytime you see an argument that affirms the consequent or denies the antecedent, you know that's an invalid and therefore unsound argument. Right? And here we're looking at four argument forms that are valid. Right? Formats that you can put an argument into that is always going to be valid. So when you evaluate the argument, you can say, well, at least I know it's valid. Now let me see if I actually agree with the premises provided. Yeah. So that's what we're doing here, right? Just to remind you. Right? So here's our final argument format that you can learn to recognize very easily. A or B, not A, therefore B. So you're saying either A is true or B is true. Let's suppose that's the case, that one of those must be true, or maybe both. But then premise number 2 says, well, it ain't A. A is not the one that's true. What logically follows? B must be the one that's true. Yeah? Is that clear? Hopefully. Okay. It's either sunny or rainy outside. It's not sunny, so it must be rainy. So, and again, you might think, well, what if there's other options besides being sunny or rainy or something like that? Yeah, but in the premise, we're not saying that there's other options, right? And so you always have to imagine the world that is described by the premises. The premise clearly says it's either sunny or rainy, and there are no other options, right? So given that that's what the premises say, you have to imagine the world as the premises say. So if the world were such that it's either sunny or rainy, nothing else, and it's not sunny, well, then obviously the only other option would be that it's rainy. Right? So whenever a statement says either this or this, and then some other statement says, well, it's not this one, then there's just one statement left over. Okay. So if we're assuming the truth of those premises, that it's one of them, but not this one, then of course we're committed to the idea that it's got to be this one. Okay. So that's a disjunctive syllogism. Well, a syllogism is basically a valid argument, okay, in a recognizable form usually. Disjunctive, you might as well learn that little piece of vocabulary as well. An or statement is called a disjunction, right? A or B, it's called a disjunction. And the two things that you're talking about, A and B, each of those is called a disjunct. So in a conditional, an if-then statement, we have an antecedent and a consequent. In a disjunction, we have a left disjunct and a right disjunct. Okay. I'll go over that vocabulary again later, but I might as well. I like to, this. I like to sometimes sneak something ahead of time, so you're not too worried about it yet, because I said you don't need to know it yet, but it's still working. It's still getting in there. And then when I really address it, we've already talked about it a little bit, so maybe you remember it. Try to do it that way. So yeah, so far you've learned that there's two different kinds of statements, right? A conditional, which has an antecedent and a consequent, and a disjunction, which is an or statement, which has a left disjunct and a right disjunct. Okay, so now I've given you a list here of arguments, and they're all arguments. They're all supposed to be deductive arguments, right? And the whole thing is, I've given you 6 different formats, right? 2 invalid formats and four valid ones. So the exercise is, well, which ones are these? Right, so I'll do a few with you, and then, yeah, that's a good stopping point. And I'll leave you to do the rest of this exercises just like last time, okay? So number 1. If giants are real, then unicorns are real. It follows that unicorns are not real, since giants aren't real. Your first job might have to be to really figure out the structure of the argument, right? To sort of, at least in your mind, put it in premise conclusion format, because this is kind of all over the place, isn't it? Yeah. It follows that means that that's a conclusion indicator, right? So the conclusion is unicorns are not real. Unicorns are not real. One of the premises must be giants aren't real because it says since. Right? Since is a premise indicator. So that means the first statement and the last statement are the premises, and unicorns are not real is the conclusion. Okay, is everyone following? So if I were to put it in premise conclusion format, it would say, if giants are real, then unicorns are real. Okay? Giants aren't real. Therefore, unicorns aren't real. What argument format is that? Does anyone know? Remember, you can figure it out. The second premise tells you what the argument is doing, right? The second premise is giants aren't real. So when you say giants aren't real, are you denying or affirming the antecedent or the consequence? Remember, the conditional is if giants are real, then unicorns are real. Is it denying any part of that? It says giants aren't real. The conditional has two statements in it. Giants are real, unicorns are real. It's denying something, right? Is it denying the antecedent or the consequence? Or the antecedent is the first part of an if-then statement. I'm waiting. I know all the vocabulary can get overwhelming. I know that. Yeah, it's denying, and it's denying the antecedent, right? Again, the first premise says, if giants are real, then unicorns are real. Right? So the antecedent says giants are real. The consequence says unicorns are real. Okay? The second premise says giants aren't real. So it's denying something. What is it denying? It's denying that giants are real. Well, giants are real is the antecedent. Right? So it's denying the antecedent, which is invalid. Okay? So it's not modus tollens. Modus tollens would be like this. If giants are real, then unicorns are real. Unicorns are not real, therefore giants aren't real. That's valid. This one is not, because it's not denying the consequent, it's denying the antecedent. Yeah? So denying the consequent would be a modus tollens, and that would have been valid. So whoever said that, it's pretty close. You saw that it's denying something. But I think because the argument is laid out in an ordinary language way and not premise conclusion format, it's a little bit more difficult to keep track. Right? It's a little bit more difficult. But if you were to break it down into premises and conclusions, and you simply look at what the second premise is doing, what it's saying about either the antecedent or the consequent, then you would know. Yeah. It's invalid, and it's called exactly what that second premise is doing. The second premise is denying the antecedent. So the argument form is called denying the antecedent. Yeah. Yep. Whereas when we get to the valid argument forms, we give it the fancy Latin term, right? Like a modus tollens, you could call it denying the consequence. We just happen to have a fancy name for it. Yeah. And in this case, it was hard to see whether it's denying the antecedent or the consequence, because you might have been looking at the unicorns part, but that's the conclusion, you see. And in this case, the conclusion was nestled inside the premises, which again, in everyday language that happens, and that's why I put it in that format sometimes, just to remind you to be on your toes to follow argument structure correctly. Okay, I'll do one more with you. I'll either watch TV or take a nap. Since I'm not going to take a nap, I guess I'll watch TV. And I mean, you also don't have the slideshow right in front of you, so it's hard for you to go right back, right? So if you didn't take good notes, this might be hard as well. Yeah, my guess is that you're not remembering what the name is. Is it valid? Is argument 2 valid? If I were to re-say it slightly more rigidly, right? I'll either watch TV or I'll take a nap. I will not watch TV, so I will take a nap. Yeah, you can see that it's valid. Yeah, an or statement. This is an or statement, right? An either or statement, A or B. That's called a disjunction, right? A disjunction. And a disjunction has a left disjunct and a right disjunct, right? So the left disjunct is I'll watch TV. The right disjunct is I'll take a nap. And so it's named after the fact that it has a disjunction in it. So it's called the disjunctive syllogism. Yes, that's right. Yeah. It's with an I instead of a Y at the beginning, but that's close enough. Yeah. Good. Yeah. Hey, but you remembered it, so that's good. So yeah, that was a disjunctive syllogism, and it's valid. Yes. Okay. I think I'll leave you to it then. See, so now, but the thing is, when you do these exercises, either use the textbook. I'm pretty sure they'll have the argument formats as well. But just use the Prezi, right? The Prezi that I'm showing you here. You could just find the Prezi, and the exercises will be on there, okay? And then you can. Oh, maybe I didn't upload the Prezi yet on Canvas. I can't remember if I did or not. I'll check right after this. But check the Prezi, right? Then you can do these exercises, and you can just scroll back a few pages to see what they were called. But it's also not a bad idea to just write it down in a notepad or something like that, or do a screenshot of it or something, just to have a handy reference. Okay? So if you look at those argument formats, it's going to be a lot easier to look at these and to think, rather than relying on your own memory like you're doing right now, right? Actually look at the chart that I gave you, right? Look at. No, you won't be able to see it right away, but I'll go over them again at the beginning of next class. Right, so you won't know right away. Oh, you know what? No, here's the page. I think it's after this, actually. Let me just go after the exercises and see if I remember. Yes, there you go. So this is another exercise you could have done, but here's just a little chart for you, right? So even if you could do a screenshot of this right now or something like that, that'll help as well. So if you have this to look at, then going through those exercises, it might be a little bit easier. Yeah. Okay, so everyone's dismissed. Have a nice weekend. Hopefully it's not too overwhelming, but spend some time with this. And to the people who are not showing up to these meetings, like I said, that's okay. You're not going to be punished for it. I was hoping for a larger turnout, because I was hoping that the people who weren't showing up were doing so because of scheduling conflicts. But when we talked about this at the beginning of the semester, not very many people had scheduling conflicts. So I don't know why the majority of the class is simply not showing up for this. I would rather they did, and I'm afraid hopefully you're at least, if I'm addressing you, you're at least watching the videos, and that's good. But also many people are not even doing that. So I'm a little bit worried about the people that are not showing up for this. But yeah, I'll sort of take stock, and I'll look at how everybody's doing on the grades and stuff, and I'll try to get caught up with grading so that I will be able to address that. Maybe it's not causing any problems. I'm not sure. But as we're getting more deeply into this, I really think, and all the people that are here right now, obviously I'm not talking to you, but to the people who are watching this later on, yeah, try to join us if you can, okay? This is going to get a bit more tricky, and this is the kind of class that's very difficult to do like this, because a lot of times with exercises, I'm used to writing them on a blackboard, but that doesn't really work in this context. Yeah, so I guess that's all I have to say. Yeah, I'll send out another email. Well, at least I'm going to take stock first. I'm going to see how everyone is doing, and then I might do that. Yeah. Yeah. Okay, yeah, well, Anna, the test will, it's going to be all online, at home. There'll be a whole week to do it, just like the quizzes. And you'll have lots of time to do it as well, and it'll be open book, right? But you can still have get anxiety, of course. But yeah, maybe the quizzes too, right? Maybe you're anxious about the quizzes. But yeah, for all those reasons, you show up to this, you can ask your questions, and if something's not clear, I can address it. And there's something about being in a more dynamic situation like this, you're probably more likely to pay attention. Whereas I kind of feel like if you just put the video on at some time, I don't know. I'm afraid also that you might just tune out more if it's not as live. Yeah. Yeah, latent learning, right? Yeah, it's some of this stuff kind of slowly gets in your head. Yeah, it starts to make more sense. Okay, so for now, try to do those exercises. Try to just look at these argument formats and look at them just as A's and B's, and try to figure out why they make sense and why the other ones don't make sense. I mean, it's one thing to just believe me and just to look at them as formulas and try to remember this formula valid, this formula invalid. Right, but it's much better if you understand why it's the case, right? Especially with something like a modus ponens. Hopefully that one is really easy to see, right? If A then B, A therefore B. I hope you see that why it follows logically, but in if A then B, B therefore A, it does not. Right? Venn diagrams will be another way to demonstrate validity, yeah? So Maggie's asking about Venn diagrams, where you use those circles, 3 circles. We will do that later for categorical logic. But it's a slightly different way of doing logic, but it allows you to see what validity is. Because when you do a Venn diagram, what's really cool is all you have to do is write down the premises. Okay, if you have an argument, then you represent the premises with symbols like that, with those circles. And then you simply look and see if the conclusion is there in the symbols. If it's a valid argument, the conclusion will just show up. So Venn diagrams do help to make this point visually. Right? This point that I've been making, that in a valid argument, the conclusion is not giving you extra information that's not already in the premises. Right? The conclusion is already entailed by the premises. And in a Venn diagram, you can see that visually represented. Because guess what? All you're doing is diagramming the premises. If it's a valid argument, that's all you have to do, because then the conclusion will just become visible to you. It's just there as well. It's just hanging out already all along, right? Whenever you have those 2 premises, the conclusion's always already hanging out with them. So yeah, Venn diagrams will help for that, to make that point. Sometimes I think I should do that first, but on the other hand, it's easier to go into propositional logic somehow with the structure of the class. Venn diagrams in psychology. What do you mean by that? Do you mean like the stuff we were talking about at the beginning of the class, or because we have not done Venn diagrams as far as I recall, and it's really only going to be applicable to categorical logic. All, some, and none statements, right? All humans are mortal. Everyone that is Socrates is human, so therefore everyone that is Socrates is human. Those are the things that we symbolize with Venn diagrams. So I'm not sure. You can clarify if you want, but. Okay, well, we are going to do Venn diagrams, it's just not until later. Yeah, I wonder what class you were going to do them in. That's interesting. Yeah. I don't know about doing Venn diagrams in a psychology class. You might have to for some reason. I don't know. Yeah, in some math classes you might have to. Yeah. Statistics, maybe. Okay. Well, I'll hang out for a bit. But you are free to go. So yeah, do both look at all these argument forms and see what makes sense and what doesn't make sense, and then try to do those exercises, right? See which of these formats they correspond to.